Now let's have a look at the output of the program. So here the program is compiled. I have used the name th99 as the executable file. You can use any other name you like. Now what we would expect is that all 6 threads should complete iteration 0 of their respective for loops. And if you look at this output, this is what is happening. This is the iteration number, and this is the number of every thread. We count our threads from 0. The first thread is 0. The next one that we formed is thread 1, thread 2, and up to 5, because we have a total of 6 threads. And after that we see that all the threads indeed complete iteration 1 of their for loop. Then we see that all threads complete the next iteration, and then all threads complete the next iteration, and so on and so on. So we have all the threads marching together. Their for loops are marching together. They are proceeding together. And finally, when all threads are done, they are going to display this by line. So this line is coming from all the thread functions, and this line is coming from the main thread, indicating that pthread join was successful. Also in the slides, I have given the output run of this program, where it was executed 2 more times, and in all the cases we see the same pattern. The expected discipline has been successfully achieved using barriers. Now in the very beginning of this program, there is this line. Let's try to understand this line now. And this is very nicely explained in this Stack Overflow question, and I have taken a part of the question answer discussion over here that serves our purpose. This thing is related to operating system standards, and you have to keep in mind is that nobody came up with all functionalities in an operating system one day. One of the main purposes of operating system standards is to keep things interoperable, which means if there are, let's say, hundreds of Linux versions out there, they should be interoperable. So we have the POSIX standard, upon which the majority of Linux is also based, and the POSIX standard defines a lot of things about the operating system, and it defines the name of the system calls, what should be the behavior of the system calls, what should happen in case errors happen, and so on and so on. And over here it is shown to you that this is something like a work in progress. You have the POSIX 1995 standard, sometimes also called the X Open 5 standard, and then about roughly after a decade we have the POSIX 2004 standard, and then after a few years the POSIX 2008 standard, and in each of these revisions or updates we have new functionalities made part of the standard. Barriers are one of those things which were not there in the very early versions of the POSIX standards. So they become available around 2004. And when you are using such kind of things which may be very recent, you need to tell your compiler about it. So you tell your compiler about which standard it should use for compiling your program. One way to do it is to use the hash define and write out x open x underscore source and you provide the number. Or you can also specify it as a flag at compile time as a parameter to your compiler, CC or GCC. So in a nutshell, barriers are a relatively recent feature and they were supported they are supported in POSIX standard 2004 and onwards, and by default your compiler may be set to use an older POSIX standard for compiling programs, and therefore sometimes you may need to explicitly specify that look, don't use the POSIX 1995 standard for compiling the program, rather move ahead and use uh, a more recent version. And finally, a short mention about a potential question which may be in the mind of you. And finally, some of you might be thinking, do we really need barriers? Can we not just use semaphores to achieve this kind of behavior? And this answer is going to be explored in an exercise that I will put out. In summary, you may be able to achieve this kind of a behavior with semaphores. But if you try to do that, you may defeat the purpose of multi-threading. And in the exercise over there, you would see that you may have a set of semaphores which would enforce a certain discipline, but it would defeat the purpose of multi-threading because it will force one thread at a time to execute. So therefore, uh, semaphores are not adequate in all kind of situations, and that is also something to think about, that if semaphores were able to solve everything, uh, there would not have been effort put into writing the code of barriers and making it a part of operating systems.